Okay, so we're going to revisit composite functions today. So this was from, well, not your SAC one, but SAC one 2019. So let's just quickly review that problem. Many of you will have probably done it at some point this year. So we've got a function, it's a linear function defined over this domain, and another function, square root function, explain with working why the composite function exists. So why am I allowed to compose this? Well, the basic process for working out whether you can compose a function will revolve around you, first of all, writing the domain and range of each of the functions. So let's get the domain of the first function, which is f, and note that it's 1, 10, and the range of the function is going to be, it's defined for 1 inclusive, 3 ones are 3, 1's 4, so when x is 1, y is 4. So there's that point there, and all the way to 10, so let's put 10 there, ignoring the scale, 30, 31. So it's going to be 31, not inclusive. Okay, so I can see my range is going to be from 4 all the way up to 31, but I can't produce 31 itself. Okay, so there's our domain and range of f. Now let's do the domain and range of g. So that's easy enough for the domain that's given to us. And that's the root function, so that's what it looks like. So it's going to have a range of g of, what's it going to be? 0, because I can produce it all the way to positive infinity. All right, now, basically to make a composition, what you've got to remember is that f of x, what it does is it accepts values, okay? So it goes, give me values. Now, the values it can accept are these ones here. So it says, I'm going to accept values from 1 to 10, not inclusive of 10. And then what it does is it produces values based on the values it will accept, and that's its range. So this is what can possibly come out of the function. Now, if that's what can come out, what we want to make sure is, what we want to do is put the result into G. So we want to get some results out of F by giving it X values. Results will come out which of these range of values. Values can be between 4 and 31. And what we want to do is make sure that G will accept all of those values. Okay, so we want to check that the range of the inner function is a subset of the domain of the outer function. Okay, so if we have a look here, what we're going to say here, this is what we're going to conclude. The range of f, which is 431, is a subset. Now that's the notation for subset of the domain of g, -2 to positive infinity. Therefore, composition g of f of x exists. Okay, so again, to conclude, what this inner function can possibly produce will be accepted by the domain of the outer function. Okay, and because it'll accept those values, we can compose the function. Now, where we couldn't compose the function would be to say, forget that that was 4 and say that it was, for argument's sake, -16. So the inner function can possibly produce a -16, but the problem is that G can't accept it because it has a domain of -2 to positive infinity. So this composition doesn't exist if the range of the function was -16, okay, but it's not. It's 4, so we can do it. So now that we can do it, let's actually form the composition. So we're going to say that h of x equals g of, now f of x is 3x plus 1. And so that means we're going to slap just 3x plus 1 into g of x. So where we see x, we're going to replace it with 3x plus 1. That's going to be root 3x plus 1 plus 2. Clean up after yourself, which means that h of x is equal to 3x plus 3, where x is an element, so we need to state the domain of my composed function. All right, so what is going to be the domain? Well, the domain of the composed function is simply going to be the domain of values that f of x will accept. Okay, so that's the first kind of thing I suppose I think about is the domain of g, okay, or no, the domain of h will be what f of x is going to accept, because that's basically the values that this function is going to work for. So we're going to say that it's just going to be 1, the 10, not inclusive of 10. All right. So just some notation, the composition of G with F is written as G. I'm not sure what that symbol is. I probably should look that up, but I'm going to go with small circle F. And the rule for the composite function is G compose F of X is equal to G of F of X. Okay, and this is just summarizing what we talked about there. If the range of the inner function is a subset of the domain of the outer function, then it's defined and the domain will be the domain of the inner function. Okay, so all of that really is what we just did when we answered these two problems there. That's the theory, whoopsie, that's the theory and that's the application. All right, so let's have a look at some other questions here. All right, let's practice a couple of skill-based questions here. So we want to get some inverses and some compositions and some inverses of compositions here. So let's just see how we go. All right, f of x equals e to the 2x, and g of x equals 1 over root x, and x is an element of all real positive. All right, so that's e to the 2x, which is going to look like that with a open circle on the y-intercept. That is kind of like the right-hand side of a hyperbola, asymptotes along there. So that's why that domain exists. All right, so f negative 1, that's inverse of that. So we're going to go y equals e to the 2x. Now our domain of e to the 2x is 0 to infinity. And our range is going to be 0, 2 to the 0, e to the 0 is 1. So that's going to be 1 to infinity. All right, let's do it. X is equal to, so we should say swap x and y. X is equal to e to the 2y. Log e x is 2y. F negative 1 x is equal to half log e x, where x is an element. So the domain of the inverse is the range of the original, so 1 to infinity. All right, there we go. B, g negative 1. So we're going to inverse this thing here. Okay, so what we're going to do is y equals 1 over root x. The domain is 0 to positive infinity. The range is also 0 to positive infinity. Right, so we're going to go swap x and y. So x is equal to 1 over root y. Let's interchange them. Root y equals 1 over x. Y equals 1 over x squared. So g negative 1 x equals 1 over x squared, where, and it's going to be this range here, x is an element of 0 to infinity. All right, so yeah, the inverse of that function is a truncus, the right-hand side of the truncus. Cool. Okay, now composition. So we want to compose, so this will be, what we want to work out is f of g of x. Okay, and that's going to be f of, now g of x is 1 over root x. And f of x is that, so we're going to see an x and put that there, so that's going to be e to the 2 over root x, where x is an element of, so it's going to be the domain of the inner. Domain of the inner is this 0 to infinity. All right, D, compose a function of itself. All right, sounds confusing, but that's going to be just g of x. Now that's going to be 1 over, and where I see x, I replace it with 1 over root x. Okay, we can't possibly leave it like that, so let's tidy it up. That's going to be 1 over Now the root of 1 is just 1. The root of a root, so that's going to be basically x to the half, which is going to be x to the quarter. And that is going to be 1 over that, which is just going to be x to the 1/4, where x is an element. So it's the domain of this, 0 to infinity. Okay, that's D. All right, E involves us inversing the composition we made in C. So there's the composition in C. So I'm just going to note that. So what are we doing? E is going to be y equals e to the 2 over root x. Okay, so we want to inverse it. So our domain is 0 to infinity. Our range is going to be, so if I slap 0 in there, root 0, 2 over 0 is undefined. Ooh, that's a bit tricky. What's its range going to be? I'm going to have to go to the calculator on this one. So let's just work it through. So I'm just going to have a look at the function itself. So 0.1, I'm not sure what this graph looks like. Where do I want to go? I want to go to graph and table, and I'm going to go shift 4, and I think it's going to be positive infinity. Range positive infinity to, all right, no, I'm not going to guess, 2 over shift root x. All right, the moment of truth. Let's have a look at this thing. Yeah, I thought it might be a bit like that. All right, so yeah, so what it's going to do is asymptote. Now that makes sense because if this is a really small number, 2 divided by a really small number is a really big number, and then e to the power of a really big number is a really big number. So it's asymptotic there. Now, as x gets bigger and bigger and bigger, it's going to root it, which makes it smaller, e to the 0. So it's going to asymptote at 1. So our range is going to be 1 to infinity. Again, I'm speculating a little bit on that. I'm just going to try it out on the calculator. So this is good for you to see me just having a play with a bit of an unfamiliar function. I'm going to do that with a value of x that's like really big. See what happens. So that's what we get. So that's getting close to 0. E to the 0 is 1. So that is almost 1. All right. And what you can see is as this gets bigger and bigger and bigger, we're going to get closer and closer to 1. So that function there looks like that, where it asymptotes along or y equals 1. All right, so now that that's been done, I actually don't know whether the bookwork requires you to do the domains and ranges, whether it's just a skill-based question, but it's worth just doing it anyway. So we're going to go swap x and y. We're going to go x is equal to e to the 2 over root y. Okay, now let's bust this out of exponential form. Log ex equals 2 over root y. Root y equals 2 over log ex. And y is equal to, so I'm going to square that, so 4 log ex all squared. Watch that vinculum there, cover the whole thing, where x is an element, so it's going to be the range of 1 to infinity. All right, so that's a pretty tough one there to get the domain and range, but if it's just a skills-based question, then yeah, it's not too tricky, just to sort of smash out the algebra on that. All right, let's do the last one. Hopefully that's a little bit easier. Okay, so we want to compose, so we want to do g of f of x. first of all. So that's f. We're going to do g of f of x, which is, what's g? What's f of x? E to the 2x. G of e to the 2x, which is, so g was, sorry about all the scrolling girls, g was 1 over root x. We want to do 1 over root e to the 2x. Okay, so there is our composition, y equals 1 over e to the 2x. All right, now our domain is going to be x as an element of 0 to infinity, because that's the domain of f of x. Our range, whoa, that's going to be hard. Range 0 is 1. I'm not sure. This is another sort of unfamiliar function, so I'm pretty comfortable with myself, well, obviously, and you guys graphing this to check it out. Over shift root, shift 4. Let's have a sneak peek. Okay, so the domain is that. So the range, okay, so we're looking at 0. So 1 looks to be the highest value it can produce. Okay, so y is an element. So 1's the best we're going to get out of it. And what we're going to get then is this asymptotic behavior as x gets bigger and bigger and bigger. So let's quickly try it out. So if we get a really large value of x, 100, that's 200, e to the 200 is big, square root that is small, 1 divided by a really big number is a really small number. So it's going to asymptote towards 0. Okay. So now we can inverse this thing. So let's go for it. We're going to go swap x and y. So x is equal to 1 over root e to the 2y. I'm running out of room here. My apologies. Now what I'm going to do is multiply both sides by that. So I'm going to go root e to the 2y is equal to 1 over x. Now I'm going to get rid of that root. So I've got e to the 2y equals 1 over x squared. So I've just squared both sides. Sorry, girls, but I'm going to have to continue this up here. Now I'm going to switch to log form. Log e 1 over x squared is equal to 2y. Y is equal to half log e 1 over x squared, where x is an element, so is going to be between 0 and 1. All right, again, domain's pretty difficult. Just check the questions before you get too far into them, girls, and just make sure that Cambridge is actually after the domains and ranges, or whether these are just skill-based questions, whether they're just looking you to inverse the function to get the result, not worried about the domain. For the really unfamiliar functions, girls, feel free to use your calc. Let's have a go at this last question here. So for the function f real positives union 0, we've got this, which is f of x equals x to the 1/3 to the 2. State or find f negative 1 and state whether f and f negative 1 is strictly increasing, strictly decreasing, or neither. All right, well, let's have a look at what the original function looks like. So that is going to be the graph of x to the 1/3, which looks like that, squared, which brings this bottom part up to there. Okay, so again, if you're ever unsure of these particular types of graphs, feel free to chuck them into your calc and just check them out. So let's just go x to the 2/3. There it is. So got that sort of cuspy behavior there. All right, so what's our domain? is the set, not the set, 0 to positive infinity. Our range is going to be 0 to positive infinity as well. Okay, so yeah, we won't take that part of the function because it needs to be 1 to inverse it. Okay, so the other thing to note is it is strictly increasing, but we'll address that later. So we're going to go and inverse the function. So y equals x to the 2/3. Swap x and y. X is equal to y to the 2/3. Now we'll raise that to the 3 on 2, raise that to the 3 on 2. And that's going to mean that y is equal to x to the 3 on 2. So f negative 1x, the inverse function, is equal to x to the 3 on 2, where x is an element of 0 to infinity. All right, now so that's f negative 1, that's the inverse function, and we need to work out whether it is strictly increasing or not. So to do that, so let's just note the original function, this one here, is strictly increasing. That's that one there. Okay, so it is strictly increasing. This one here, now what does that function look like? F negative 1x equals x to the half power 3'd. Okay, so that's the root function power 3'd. Okay, so what it does is it creates like the right-hand side of a parabola. Okay, and again, you'll note that it is also, that function there is strictly increasing as well. Right, so again, feel very comfortable just checking these graphs on your calculator. After a while, you'll get to sort of pick the function behavior, but it is good practice just to have a look at them and note that we've got a strictly increasing function. All right. So the homework, girls, 7B, those questions there.